Hi everyone, my name is Sophia Chavez, and today we're going to be going over nomenclature and naming organic compounds with multiple functional groups. So let's get started. So firstly, we're going to define what exactly are organic compounds. They are chemical compounds that are composed of carbon rings or chains, and they're covalently bonded to usually hydrogen, nitrogen, and oxygen. And this nitrogen, hydrogen, oxygen typically make up the functional groups, which we'll be going over shortly. But as you can imagine, with so many possibilities of compounds, a naming system is necessary to distinguish all the different compounds. And the system mainly used for organic compounds is the IUPAC nomenclature system. And this is the main system used, like I said, and the purpose of the system is to define all these different possible compounds while at the same time giving or defining the structure of the compound. And so the main three things that this naming system does is that it specifies the carbon ring or chain and its basic structure, it specifies functional groups in the compound, and it names these substituent groups, which are the side groups. So now we're going to go over what are functional groups. They're groupings of atoms attached to the carbon chain or ring, and they give the compound its properties. And oftentimes, compounds with the same functional groups will share similar properties and characteristics. And in these functional groups, there is a list of priority, which we will go over shortly in terms of naming. So the rules for naming. So firstly, you're going to identify the main carbon chain, which is going to be the longest chain, and it also must include the functional group of highest priority. Like I said, we will be going over that list shortly. And then after that, you're going to identify all the functional groups, and the substituent groups will be all the functional groups that are attached to the main chain that are not the highest, that don't take the highest precedence in that compound. The number of carbons on the chain must be numbered so that the functional groups pertain to the lowest carbon number. So you're going to pick a side from which to count the carbon so that it is in the lowest, or so that the functional groups pertain to the lowest number. And then when you're putting the name together, you're going to list the substituent groups in alphabetical order with the locant coming from the name. And if two of the same substituents are placed on the same compound, you're going to place di or tri or how many there is before that name after specifying their location. So we're going to go over the basics pretty quick. But the basics, hydrocarbons, we know that they're compounds made up of carbon and hydrogen, and we call these alkanes. So when they don't have any double or triple bonds. And of course, they're named in a two-part system. The first one indicating the number of carbons, so prefix, and the suffix will be ane. So if you have 1 carbon, it's going to be methane. If you have 6, it's going to be hexane. And if it's a carbon ring, we're going to put cyclo in front of that. So if you have a carbon ring of 6 carbons, you're going to call it cyclohexane. Then we have our alkenes and alkynes. That's simply an alkene has a double bond, and alkyne has a triple bond as well. And this will be specified in the name along with the locant beforehand. Okay. And now we're moving on to alkyl and alkyl halides. This is just a really short summary since I'm sure we're all pretty familiar with this, but alkyl halides is pretty simple. You just change the fluorine to fluoro, chlorine to chloro, and for alkyls that are side chains, you're just going to change the ending to YL. So if you have 1 carbon side chain, you're going to put methyl. If you have 2, ethyl. Okay, moving on to alcohols. They have a hydroxyl group, an OH, and in order to name them, we're just going to change the ANE ending with anol. And if it were to have a double bond, so it had an ENE ending, we're going to change that to enol. If there's multiple alcohol groups, we're going to put di or tri in front of it after specifying their location. And if there is another functional group that takes precedence over the alcohol in the same compound, we're going to name it as a substituent group, giving it the substituent group name of hydroxy. Moving on to ethers, they have the formula ROR, but the R simply stands for the hydrocarbon chain or ring attached to the oxygen. So it's going to have 2 different types of groups, or it could be the same, attached to that oxygen. And to name them, there's simply a space put between the 2 names and ethers put at the end. And if there are the same alkyl group, so here at the top we can see it has dimethyl ether, then you're going to put a di in front of that name. And as a substituent, it is named oxy as a suffix. Okay, so our aldehydes and ketones. So these are both going to contain a carbonyl group. The aldehydes are going to replace one of the R's with a hydrogen, whereas the ketones are going to have the both R's as alkyl groups. Aldehydes are given the suffix al, while ketones are given the suffix ono, and both the substituents are given the name oxo. So as we can see here, as a simple example, methanol would have been methane, but as we have that carbonyl group, we're going to name it methanol, replacing the E with an al. As well as here, we have propanone. As you can see, 3 carbons would have been propane, but because of that carbonyl group, we're going to put that as propanol. Okay, next we have our carboxylic acid. So this is going to have your carboxyl group, which is just a carbonyl group with also a hydroxyl group. And this one is actually going to take precedence over all other functional groups, and we're going to give it the suffix anoic acid. Here's a simple example. We have 1, 2, 3, 4 carbons, that hence the boot, and then we're going to place the ending with anoic acid. Okay, so next we have esters. So this functional group consists of 2 components. We have an alkyl group and we also have our carbonyl group. And as you can see here, attached to our oxygen, we'll have some type of grouping here, as well as on this one, another group as well. So for naming, the alkyl is named as a substituent group. So whatever is attached to the O, we name as a substituent group. And then from the other side, attached to the carbonyl group is going to be what takes the O8 ending to it, kind of you can think of as the main chain, even though this whole thing is the main chain. But here, for example, we have methylpropanoate, so he has 1, 2, 3 carbons, hence the prop. Then we have a methyl group here, 1 carbon, so we're going to have methylpropanoate for the ester. Next we have our amines. So these are organic derivatives of ammonia, NH3, and they can either be primary, secondary, or tertiary, and that depends on the substituents attached to the N atom. So we have primary amine, secondary, and tertiary. As a substituent is named amino, and if it has 1 alkyl group, it's going to be attached to the N. And then if any other ones, if it moves to secondary or tertiary, it's pretty simple. You just add the N as the locant in the front. So as here you can see that it has a methyl group attached, so it's N-methyl propanoate, hence 3 carbons, 1 amine. Okay, next are amides. So in this one, we're going to replace the hydroxyl group that would have been in a carboxylic group by NH2. And for naming, we're going to put it as an amide, which replaces the ane. In a substituent group, if that's attached to the N replacing the H, the N is put as the locant. And here we can see that we have 2 carbons, so ethane. But we do have the enamide group right here, so we have ethanamide. And then we have 2 substituent groups attached to the N, so it's going to be dimethyl NN. So all of that together will be NN dimethyl ethanamide. Okay, so here we have our list of priority, and this is really important to keep in mind when you're naming or drawing out these structures. As you can see here, our carboxylic acid takes precedence over all of these different kinds of groups. So for example, if you had an alcohol and a carboxylic acid on the same compound, you would not use the OL ending, you would use the OIC ending, and you would use the hydroxy, so the alcohol, as a substituent group instead. Okay, so now we're just going to go over some practice examples. So we have, to make the longest carbon chain, 1, 2, 3, 4, 5. So we're going to go with pentane. Then we're going to identify the functional and substituent groups. So here we can see that we have our carboxylic acid. Here we have an alcohol, and here on the side we seems to be an ethyl group with 2 carbons. Numbering them so that the group of the highest precedence, the carboxylic acid, takes the lowest carbon number. We're going to go 1, 2, 3, 4, and 5. And with that, we're going to give the name 3-ethanol 2-hydroxy pentanoic acid. Moving on to the next one, we're going to count out our carbons. 1, 2, 3, 4. Okay, so that's going to give us butane. And now identifying our groups, it seems here that we have an amide, and here an amine. Numbering them so that the amide takes the lowest number of carbon. We have 1, 2, 3. We're going to give it the name 2-aminobutanamide. Moving on to our last one here, we're going to count it out. 1, 2, 3, 4. It seems to be our longest, so we're going to have butane. And now we're going to identify our groups. So here we can see that we have an amino group. Here we have an alcohol. Here a methyl group. And then here a double bond. Numbering them so that we get the lowest for the amine, which is going to be of our highest precedence. It's going to be 1, 2, 3, 4. And we're going to get the name 1 amino, 2 methyl, 3 butene, 2 all. Okay, so applications of organic nomenclature. So evidently they help you distinguish between different types of compounds, as coming up with a name for each would just be impossible, coming up with a common name. And also these common names don't really tell you anything about the structure, whereas our IUPAC system gives you tells you the structure of the compound and specifies the functional groups. And this is particularly important because knowing these functional groups gives you an idea of how the compound is going to react, because functional groups share common properties. So for example, here we see an alcohol group, which is the rest of the carbon chain attached to the OH group, and this is going to make it bent. It's going to give it similar to the shape of water, and that's going to make them polar. And the presence of the OH group also allows for hydrogen bonding, and this allows for a higher boiling point. As well as with carboxylic acids, typically these have the physical properties of having higher boiling points and are polar as well. And knowing this information is so important for chemists, for scientists, because it gives them an idea of how the compound is going to react and physical properties that it shares. Okay, thank you so much for watching. That concludes the end of this presentation. Here are the list of references that I used throughout the slides that you can check out yourself if you want some further knowledge on nomenclature. Thanks so much.